Algebra 2, Lesson 1-4. I'm recording this in case next year's class I'm not there for whatever reason. All right, so let's talk about input and output. So if I have an input and I am transformed by some function, so I'm going to call this function f. Write this down. The function f takes that input and it gives you an output. That is the output of function f. That output is now going to be the new input. So we're going to do like a giant slash right here. That's going to be the new input. It's the same number, but it's going to be the same input for a new function. We'll call it g, and it will create a new output. So the input gets transformed by f, turns into output, and that output is the same as the input that goes into g, which turns into the output. The units here matter. Units are suddenly super important. And I will tell us why. So if I have an output here, I guess this is the most important part. Draw arrows to here and here. Or I guess we should say this, not this, these. This needs to be able to go into G. For example, if G only accepts dollars and you try to insert apples into it, it's not going to work. It's going to break this machine, this function. You need to make sure that your output and input are correct. We'll talk about that more when we look at example 1. All right, so this is Mr. Sandell's own example. I modified a question from Khan Academy to make it my own. This is almost exactly what you'll see on Khan Academy though. All right, so I noticed a few quantitative relationships in my class, and I modeled them with the following equations. So L, T, and M, these correspond to what that function is called. So for example, this will be L of H is my function. So my input for L is your average score on homework. Your average score is going to be represented by the variable H. Your output, so this function will take in what your score is on homework and it will output your score on quizzes. So, okay, I got a 90% on homework, blah, 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 go through the function, do, and it turns into an 80% on quizzes. I found a formula, bless you. I found a formula that converts your homework score into a quiz score, your anticipated quiz score. I found another function, I call this function T. You put in a quiz score and it spits out a score on a test. So let's say, for example, I know that I averagely get 85% on quizzes. I go through my function, and all of a sudden I know on my test I'm going to get a 73%. That is my function. Whatever it does, I don't know exactly the workings, but it inputs. The input is a score on a quiz, the output is a score on a test. And finally, function M, number of times that you participate in class. So let's say James participates 5 times in class. Well, I can use my formula M and tell you, oh, I know what your average score is going to be on quizzes based on how many times you participated. Are there questions about how these functions work? What do they input? What do they output? Cool. Okay, so here's the question. What does this expression T composed with L of H represent? So I want you to think about that for 10 seconds. What does that represent? What is the input? What is the output? That was 10 seconds-ish. So I'm going to give you a hint, and then I want you to start talking with people around you. The hint is this guy right here is the innermost parenthesis, the H. That should be the input. The output should be whatever you get from the very outside. Once you're done transforming all of that, talk to people around you. What's the input? What's the output? Go, talk. Okay, not very much talking. Input and output. Write it down. This function, this composition of functions, it takes in something. Quiet raised hand. What is the input of t composed with L of h? What is the input? I need the variable and what the variable represents. Fiona, go for it.
The variable is
H, okay.
It represents average.
Yep, H. Average score on homework. Let me come over here to Fiona, give you your XP. Perfect. All right, so H is being fed into this function L. L will transform H, right here, into this, average score on quizzes. So right now, this whole block right here represents average score on quizzes. Now that's being fed into a new function, T. Average score on quizzes goes in. Oh, perfect. This T accepts that as an input. You have to check that it's okay to accept that as an input. So I take in average score on quizzes, that giant circle, and I spit out average score on tests. That is our output. This whole thing outputs this average score on tests. So the output is, I'm just going to not even do a variable here. It's just going to be average, come on now, computer. Average score on tests. All right, then we have multiple choices, just like Khan Academy. We know what our input is, we know what our output is. Go ahead and read A, B, C, D, and E. Decide what it is by yourself, then check with a partner. Go for it. All right, so we're back. All right, we're gonna do fist of 5. A represents 1, B is 2, C is 3, D is 4, E is 5. Hold up your guess. If everyone takes a guess, everyone gets 10 XP.
I had some guys. Okay.
I see mostly 1s and 2s and a few 4s. Interesting. Okay.
Wait.
Bless you.
Thank you.
All right, so the way that you format the answer here is it's going to be blank as a function of blank. This here represents your output. Output as a function of input. So our output is average score on tests. So we should say average score on tests as a function of. Average score on tests, so it's not this one, that's average score on homework. Average score on tests, and it might, yeah, it's probably not E. So it's either A, C, or D. And our input is average score on homework. So as a function of average score on homework, the correct answer here looks to be A. Yeah, it's A. Because our input was average score on homework. And it says average score on homework, that's our input right here. Perfect. Are there questions about this first example? All right, I'm going to use the same problem up here. So let me go ahead and do a little bit of erasing. Use this first example and ask a new type of question. What does the expression L of T of H represent? Now I want to walk through this with you guys because it's still a little bit difficult, I imagine. All right, our input here is still H. We're starting with H. It's the same input, so it's average score on homework. To find what our output is, we just walk through the steps. So H gets fed into the function T. Let's look at what happens. H is average score on homework. We're going to put that into function T. Average score on quizzes. Uh-oh. We've broke this function. It was asking for money and we inserted apples. It's going to break the function. We can only insert H into function T. So we've broken the function. Correct answer here is E. None of the above. That is meaningless. You're not allowed to do that. It broke that rule up here at the top that we were talking about, that this input slash output needs to be able to go into the correct function. H was not even able to go into T. So it doesn't mean anything. All right, let's go to the backside. I have another example, and our final example. All right, there's a lot to read here. I need someone to read all 3 of these paragraphs. Quiet raised hand. Who wants to get some XP? Go for it, Andrea.
Mr. Sindel estimates that the winning chance W of beating another school given that X fans is modeled by the function W of X equals X over 3 plus 10. He also finds that the relationship between how many fans our school has at a game, F, is related to the temperature in Celsius for the game date, T. This is modeled by the function F of T equals 2T plus 50. Find an explicit function that models the winning chance of beating another school given that the temperature in Celsius for the game date is T.
Perfect, thank you. Okay, boiling this problem down. Essentially what it's asking for is do a composition of functions. We have one function here, w of x. We have another function here, f of t. One goes inside the other. Your job is to figure out which one goes where and then to evaluate it just like we did on the warm-up. All right, so I want you to think about this for at least 30 seconds. Which function goes inside of the other function? Then check with the partner. So think about it right now for 30 seconds by yourself. We're back. Okay, so you all had time to think about if F goes into W or if W goes into F. Which one is it? Quiet raised hand. Eva, go for it.
F goes into W.
F goes into W. Why?
I don't know.
What? Let me point my question a little bit better. How do you know that the second function has an input that is given by the output of your first function? Saying that another way, how can you guarantee that W's input is given by F's output if you're putting F into W? Still confused?
Yeah.
Okay, let me ask that as a two-part question. First, what is the output of F? What does F output? This is for Eva. So I'm looking at this function f. What does f give you? What is the output of f?
Celsius or temperature, T.
Not quite. It's in the first part of the sentence.
How many fans?
Yeah, how many fans? So let's write this down. Everyone in our notes. We're looking at f right now. That was a bad f. F. Input for f. The input is temperature. The output is, as Eva told us, number of fans. Now let's look at the function w. And I'm going to wait on giving you your XP because we don't exactly know if you're right or wrong yet. All right, I need a quiet raised hand. What is the input of w? That function w, what is the input? Go ahead and read the problem again. W, it's in that first paragraph. What is the input? Not exactly. But you're close. It's the other one. That's still talking about the winning chance of beating another school. Given what? Fans, yeah. So the input here is number of fans. The output, however, the thing that W tells you is your winning chance. So I'm going to say, again, not spelled, winning percent or something like that. So by writing these out, I hope it makes it a little bit clear that if I put F into W, I first evaluate F, I get a temperature, it outputs number of fans. this number of fans should be the input of W, and it is. This output and this input, these two guys, and that's the most important part of this lesson, these two outputs and inputs, they match. Because they match, F goes inside W. If I bid W inside F, winning percent and temperature, these two would have to be the same, but they're not. Because the output of F is the input of W, you are allowed to put F into W. I can write that out in words too, because I think it's important. The output of F, remember F is that function, is the input of W. I will give someone not only XP, but 1 point of extra credit if you know the symbol for therefore. Steph. 3 little dots like,
Triangle.
there it is, yeah. So on your extra credit tracker, on the very back of your page for miscellaneous points, give yourself 1 point and I'll come sign it. Therefore, this is the symbol for therefore. Write it down in the side if you didn't know that. Therefore, F can be inside W. Like that. All right. So the output and the input, those are the key guys. All right, we're almost there. So now that we know that F can go inside of W, we need to actually do that. F is 2t plus 50. So this is what we're finding. Please write this down. We're trying to find W of F of T. We know T is the inside because it tells us given blah, 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 T. Given the temperature in Celsius for a game day is T. So we're given T, that's our input. Given our input, find the winning percent chance. So now we need to do that. F of T, again, is 2T plus 50. That is going to be inserted into this X up here. So I'm going to rewrite this expression, but in the place of X, I'm going to write 2T plus 50. So here it is. This is equal to. There's my fraction. That's where X used to be. It's X over 3 divided by 10. So there's X over 3. Did I say plus 10? I meant to say plus 10. I might have said divide by 10. And then inside where this X used to be, this F of T is going to be. And F of T again is at the top. F of T is 2T plus 50. So 2T plus 50. And I ran out of space here. 2T plus 50. That's your final answer.
How do you get 2? Where did 2 come from?
Oh, there you go. Oh, never mind.
Oh, you got it? Okay. All right. I know that was hard. The main point is that the output of one function needs to match with the input of another function. Are there any questions about this lesson before we begin with our problem set? I'll help us with the problem set. I know that we'll need it. All right. Please write your summaries. Once you checked someone else's summary after writing your own, you can move on to the problem set on Khan Academy.